In this video, we're going to be talking about the division algorithm. So the division algorithm says that if f of x and d of x are polynomials such that d of x doesn't equal 0, and the degree of d of x is less than or equal to the degree of f of x, then there exists a unique polynomial, we'll call it q of x, and r of x, such that f of x equals d of x times q of x plus r of x, where f of x is our dividend, d of x is the divisor, q of x is our quotient, and the r of x is our remainder. So now where r of x equals 0, or the degree of r of x is less than the degree of d of x, the remainder r of x is 0, than the degree of d of x. Now if the remainder r of x is 0, then d of x divides evenly into f of x. So what does that look like, not as an algorithm? So what it's saying is that our divisor is the piece out front, the piece inside is the dividend, the piece on top is our quotient, and whatever we get down here is our remainder. So in this situation, because we have a 0, it's saying that our r of x, not the r of x, that our d of x divides evenly into our f of x. So there's some important things to know before you apply the division algorithm. There's some steps to follow. You want to write the dividend and the divisor in descending powers of variability. Descending powers of variability. And you want to insert placeholders with 0 coefficients for missing powers of a variable. So we're going to do an example, and hopefully that will help make sense a little bit. So we're going to take 8x to the third minus 1 and divide it by 2x minus 1. So let's go ahead and set that up. So we'll have our 2x minus 1 divides. Now, so we have our 8x cubed, but there's no squared. So we put 0x squared plus 0x minus 1. Because we need to make sure that every point is represented, right? So that we insert placeholders with the 0 coefficients for missing powers of the variable. And that's what we've done. So here's our 0 coefficients for those missing powers. And so now we're ready to divide these. So we're going to take our first thing. So that's the 8x to the third. So our leader of our country. We're going to divide it by our lead SPY, which is the 2x. And that is going to give us a 4x squared. And so we're going to put that on top of our squared term. And then we're going to multiply. So when we multiply the 4x squared to the 2x. And that gives us an 8x to the third. Oops. Let's try that again. To the third. And then we're going to multiply our 4x squared to the negative 1, which gives us a negative 4x squared. Then we have to take each of our symbols that we just wrote and make them opposites. Then we're going to combine these. So that goes away, and we get 4x squared. We bring down our remaining pieces. So plus 0x minus 1. And so now we're going to take our new leader, which is the 4x squared. I'm going to take that, and we're going to divide that by our SPY, which was the 2x. So again, there's our SPY, 2x. And when we do that, 4 divided by 2 is 2, and x squared divided by x is x. So we'll put a positive 2x on top of that term. Then we're going to multiply 2x times 2x, and that's going to give us a 4x squared. Then we're going to multiply 2x times negative 1, and that's going to give us a negative 2x. And then remember, we have to switch those symbols. So we're going to switch the symbol, then we can add those together. So that will go away, and we'll get a 2x minus 1. And so now we're going to take our new leader, which is the 2x, and divide it by our SPY, which is this 2x. And if we take 2x and we divide that by x, or by 2x, that's going to give us a 1. So we're going to go ahead and put a plus 1 up there. And then we're going to go ahead and we're going to multiply. So 1 times 2x, which is 2x, and then 1 times negative 1, which is negative 1. Then we're going to switch our symbols, and then we're going to add those. So we're going to get a 0 and a 0. So we're going to get a remainder here of 0. And so we're able to write that 8x to the third minus 1 divided by 2x minus 1 equals 4x squared plus 2x plus 1, and there's no remainder, but we do need to say that x is not allowed to equal a positive 1/2, because a positive 1/2 would make our denominator a 0, which we can't have. And so here we have our solution. So we're going to go ahead and do one more. So in this one's a little bit bigger. Here we have 2 plus 3x minus 5x squared plus 4x to the third plus 2x to the fourth divided by x squared plus 2x minus 3. Whew, that's a mouthful. All right, so we're going to start off by rewriting this first one. 2x to the fourth. I'm going to write it in order. 4x to the third minus 5x squared. It's really just been written backwards, and we want to write it the right way so we don't mess it up. All right, so we're going to have x squared plus 2x minus 3 divides 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. We didn't have to put in any 0 placeholders because there was a 4th degree, 3rd degree, 2nd degree, 1 degree, and then no variable term. And so we have everything that we need. Same thing over here. We had a square, we had a single, and we had a constant. So we had everything that we needed. We didn't need any 0 terms. So now we're ready to divide this. So we're going to take our 2x to the fourth and divide it by our x squared, and that's going to give us a 2x squared. So we'll put that on top of our squared term, and then we need to multiply this, right? So we're going to multiply this here, and that's going to give us a 2x to the fourth. Then we're going to multiply that with the 2x here, which is going to give us a positive 4x to the third, and then we're going to multiply it with the negative 3, which gives us a negative 6x squared. Then, just like we did earlier, we're going to change all of our symbols. We're going to combine these. So we're going to get 0, and that's nice. That's a 0 as well. And then here we'll end up with just an x squared. And we'll bring down our remaining terms, and we'll move on to the next piece. So now we're going to take our x squared, so that's this piece right here, divided by this piece right there, and they happen to be the same. So we can say that x squared divided by x squared is a 1. So we can put a 1. Now notice that I'm going to put it over here in this spot because this is the x term, and 1 doesn't have an x with it. So I'm going to take my 1, and I'm going to multiply it with the x squared, and that is going to give me an x squared. Then I'm going to take my 1 and multiply it by 2x, and that's going to give me a positive 2x. And then I'm going to take the 1 and times it by negative 3, so I get minus 3. So I go through and I change all my symbols to the opposite thing. Then I can combine those, and that's going to go away. But here I'm going to be left with an x plus 1. I'm left with an x plus 1. So this is how I would write this. I would be able to say that 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 equals 2x squared plus 1 plus, and that's where this next part comes in. I'm going to take my remainder here, right? It's got my remainder, x plus 1 over x squared plus 2x minus 3. And so we have what our problem was right here, right? It's our problem. And then this was the solution that we got. The most common mistake is that people forget to write the remainders. So don't forget to write your remainder. Make sure you put that on there. Get all your points. And so again, this is our solution.